Now let's see how we did in real world terms. How well it actually classifies students being on probation or not. So what is a classification table? So when we run a logistic regression, we're predicting probabilities. Like this is a student that has a 73% chance of being on academic probation. But at some point, we do have to make a decision. Do we classify them as at risk or do we classify them as not at risk? That's where the classification table comes in. It's going to summarize how well the model translates probabilities into actual predictions themselves. So what SPSS is doing is it's taking what actually happened, which is the true outcome, and then what the model predicted, which is based on a cutoff point. And by default, and you can actually change this in the settings as well, should you want to, that cutoff is 0.5. If a student's predicted probability is above 50%, the model classifies them as on probation. If it's well below 50%, they're classified as not on probation. So why 50%? Because logistic regression produces probabilities between 0 and 1, and 0.5 is the natural midpoint. It's like a reasonable default if your outcome classes are balanced. But if your data is skewed, like in our case, where only 14% of students are actually on probation, that threshold might be too high to catch the cases we care about. So the way in which to read the table itself, the table's got 4 cells. You've got the predicted no against actual no, which is your true negative, and then the predicted yes against the actual yes, which is your true positive. And now when you've got the predicted yes against the actual no, you've got your false positive rates. So we felt like they were going to be on probation, but actually they weren't the case. So we got it wrong. And then the predicted no against the actual yes, whereas where we missed on the end we're actually interested in, that's what we consider false negative. And from this, what we can calculate is 3 things. So accuracy is how many predictions were correct overall. Sensitivity, or often called recall, is how many of the true cases we actually caught. And then specificity, how many of the true no cases we correctly identified. And then here's a way to actually look at how they're calculated. So let's take this percent correct on the actual no against predicted yes. You're taking that base value of 1225 and then dividing it by 1225 plus 18 and gives you the percentage accurate here at a 99%. So what it's telling us is how good we are at predicting those that didn't, that actually were not on probation. But then when we take the percent correct on the yes against the actual, or the predicted yes against the actual yes, we have 21 divided by 21 plus 189, telling us we only got 10% correct. So that tells us that we are only at a 10% prediction clip of getting a true positive correctly. So then what we do then from there is we can actually take both values, the 1225 and the 21, add those, and then take the actual total, which is the full base, and that gives us what our proportion of accuracy. So our total accuracy rate is 85.6%. So this is not about 99, that's about 10, but because the base rate, or the base of the entire population is much less likely to be on probation, it's going to err on the side that we're very good at getting this right, but where we need to make up for it is getting better at the true positive rate. So in our model itself, we got 98.6% of students who weren't on probation correctly identified, but only 10% who were actually on probation we were able to flag. So that gives us an overall accuracy of 85.8%, which sounds good, but it misses the very students we're trying to find. So this is why you don't want to just look at accuracy. You want to ask, am I catching the students who need help? And if I'm not, maybe I need to lower the cutoff point to 0.4, 0.3, something that makes it more sensitive. We might try a resampling technique like SMO to rebalance, or simply reframe the goal. Do I want to be cautious and do we want to cast a wider net? The final takeaway here is the classification table shows us how well our model moves from probability to decision. It's a powerful tool, but only if we interpret it in context, especially when we're dealing with imbalanced outcomes like student risk in this case. So looking at the classification table itself, let's go through each of these components. So our model here is excellent at identifying students who are not on probation with a specificity here score of 98.6%, but it struggles to correctly identify students who are on probation, which is our sensitivity score at 10%. Our overall accuracy of 85.8% Looks solid at first glance, but remember that's mostly due to the imbalance in the data because most students aren't on probation, only 14 or so half percent. So this is a class imbalance problem. Only 210 students in total, which is the 21 plus 189, were on probation out of the 1453 total, about 14.5%. So the model leans on the safe side because to most perfectly predict not on probation because it's correct most of the time. So that's why even with 14 predictors, your model still struggles to flag students who actually need help. It got 98.6% of the non-probation cases right, which is great, but it only correctly flagged 10% who actually ended up on probation. So it's telling us something important. While our model is good at spotting students who are doing fine, it's not so great at identifying those who are struggling. And that's the group we really want to catch early. The overall accuracy rate of 85.8%, that number's a little misleading. It mostly reflects the fact that most students aren't on probation to begin with. When we run a logistic regression, we're predicting probabilities, like the student has a certain percentage chance on being academic probation. But at some point, we want to make a decision. Do we classify them as at risk or not at risk? And that's where this classification table comes in. It summarizes how well the model translates probabilities into predictions itself. And now where the magic happens. Hope you enjoyed this. If you got value out of it, go ahead, hit subscribe, and look forward to putting out more videos for you.